Why are RL agent hyperparameters so sensitive? Imagine trying to tune a musical instrument where a tiny turn of the knob can change the entire sound. That's what working with reinforcement learning agents feels like. It's all about getting the settings just right. Reinforcement learning agents learn by interacting with their environment, kind of like a person learning to ride a bike. They get feedback based on their actions, which helps them improve. But the tricky part is that small changes in hyperparameters can cause big differences in how well they learn. Hyperparameters are the settings that control how the agent learns. These include the learning rate, which tells the agent how fast to update its knowledge. If it's too high, the agent might jump to wrong conclusions. If it's too low, learning can be painfully slow. Then there's the discount factor, which determines how much future rewards matter. A high discount factor makes the agent focus on long-term gains, while a low one makes it focus on immediate rewards. The exploration rate controls how often the agent tries new actions instead of sticking to what it already knows. Too much exploration can slow down learning, while too little can cause the agent to miss better strategies. The reason hyperparameters are so sensitive is because of how these settings interact with each other and the environment. In reinforcement learning, the environment is often changing or unpredictable. This makes the agent's learning process unstable if the hyperparameters aren't just right. A small tweak can cause the agent to get stuck in a bad strategy or behave randomly. Another factor is that reinforcement learning algorithms are complex. They involve feedback loops where the agent's actions influence what it learns next. Changing a hyperparameter can disrupt these loops, leading to unpredictable results. Because of this, tuning hyperparameters isn't a one-time thing. It often takes multiple tries, using methods like grid search or automated tools to find the best combination. Unlike supervised learning, where default hyperparameters often work well, reinforcement learning needs careful adjustment for each task. Different environments and goals mean that what works for one scenario might not work for another. That's why hyperparameter tuning is a vital part of developing effective reinforcement learning agents. The high number of hyperparameters and their interdependence make tuning a challenge. Adjusting one can change how others behave, making the process more complex. This sensitivity is why reinforcement learning developers spend so much time experimenting and refining settings. In real-world applications like robotics or game playing, poor hyperparameter choices can lead to failure or unsafe actions. That's why understanding this sensitivity is key to deploying reliable reinforcement learning systems. It also highlights the importance of using automated tuning tools and systematic search methods to find stable, effective settings. So, in essence, the reason reinforcement learning agents are so sensitive to hyperparameters is because of the dynamic, feedback-driven nature of their learning process. Small changes can ripple through their behavior, making tuning both a challenge and a necessity for success.